In 1770, a machine could calculate square roots with perfect accuracy. Another could write poetry with a quill pen. A third could navigate the open ocean using only the stars. These were not computers, they were pure mechanics, gears and springs. We remember the 1700s for the Industrial Revolution. But before steam engines and factories dominated, there existed a golden age of mechanical ingenuity that history has largely forgotten. These technologies required no electricity, no digital circuits, just brilliant minds and masterful craftsmanship. And then they vanished. Why did we abandon these sophisticated mechanical systems for the brute force of steam and coal? What knowledge did we lose in the process? Today, we uncover the lost technologies of the 1700s, machines so advanced they seem impossible for their time. The 1700s were a peculiar time. Europe was emerging from centuries of tradition. The Age of Enlightenment had arrived, bringing with it a belief that human reason could solve any problem. But this was before factories, before mass production, before the smokestacks that would define the Industrial Revolution. In this world, every machine was handmade. Every gear was filed by human hands. Craftsmen were not just workers, they were artists. Clockmakers, instrument makers, and mechanics spent decades mastering their trade. A single complex machine could take years to complete. This was the era of the curiosity, mechanical devices designed not for mass markets, but for wealthy patrons who appreciated artistry and innovation. Kings and emperors competed to own the most impressive mechanical wonders. These were status symbols, conversation pieces, and genuine technological marvels. But these machines had a fatal flaw. They were too complex, too expensive, and too dependent on individual skill to manufacture. When the Industrial Revolution arrived, promising cheap mass production, these delicate technologies stood no chance. The transition was not gradual, it was a collapse. Within decades, centuries of accumulated mechanical knowledge became obsolete. Workshops closed, masters died without apprentices, blueprints were lost or destroyed, and with them, an entire philosophy of technology vanished. Let's examine the technologies that defined this lost era. First, the calculating machines of the 1700s. In 1777, Charles, the third Duke of Brunswick, commissioned a machine that could perform complex mathematical calculations automatically. Using nothing but gears and levers, it could add, subtract, multiply, and divide with perfect accuracy. But the most sophisticated was the arithmetometer prototype, decades before the famous 19th century version. These machines used intricate gear trains and carry mechanisms that would not be fully understood again for 100 years. Second, mechanical automata. These were not simple toys, they were programmable machines that could write, draw, and play music. The writer automaton, created in the 1770s, could be programmed to write any text up to 40 characters. Its CAM system, essentially mechanical memory, controlled every movement of the hand, arm, and even the dipping of the pen in ink. The drawsman could draw 4 different pictures, including a portrait of King Louis XV. The musician could play a real harpsichord, reading mechanical notation and adjusting finger pressure. Third, precision navigation instruments. The 1700s saw the solution to the longitude problem, determining position at sea. John Harrison's H4 chronometer, completed in 1759, was a marvel of miniaturization and precision. It could keep accurate time at sea despite temperature changes, humidity, and ship movement, losing less than 5 seconds per month. This was not just a clock, it was a mechanical computer that solved one of the greatest scientific challenges of the age. Ships could finally navigate accurately across oceans. But these magnificent machines faced an existential threat. The Industrial Revolution was not just a technological shift, it was an economic and social earthquake. The new philosophy was simple: speed, volume, and profit. Why spend 2 years crafting a single precision automaton when you could mass-produce 1,000 simple toys? Traditional craftsmen found themselves priced out of the market. A handcrafted calculating machine might cost a fortune and take years to complete. The new industrial machines were crude, but cheap and fast. Wealthy patrons, once the primary market for mechanical wonders, began investing in industrial enterprises instead. Why commission an expensive automaton when you could buy shares in a textile mill? The apprenticeship system collapsed. Young people flocked to factory jobs instead of spending decades mastering a craft. The transmission of knowledge from master to apprentice broke down. But the final blow was philosophical. The Enlightenment ideal of progress became twisted. Complexity and artistry were seen as wasteful. Efficiency became the only virtue. Mechanical wonders were reclassified as toys or curiosities, not serious technology. The sophisticated knowledge required to build them was dismissed as impractical. The collapse was swift and brutal. By 1800, the great age of mechanical ingenuity was over. Workshops that had taken generations to build closed their doors. Master craftsmen died without passing on their secrets. Tools were sold for scrap. Blueprints were burned or lost. The calculating machines were dismantled for their brass and precious metals. The automata were broken, their complex mechanisms scattered or destroyed. Navigation instruments survived longer, but even they were eventually replaced by simpler, mass-produced versions. The extraordinary precision of Harrison's chronometers gave way to good-enough industrial timepieces. By the mid-1800s, few people even remembered that such machines had existed. They became legends, myths, stories of impossible devices from a romanticized past. The knowledge didn't just fade, it was actively suppressed. Industrialists had no interest in promoting technologies that celebrated individual craftsmanship over mass production. What survived was scattered across Europe in private collections, forgotten in museum storage, or hidden in attics and estates. But the story doesn't end in darkness. In recent decades, historians, engineers, and craftspeople have begun to rediscover these lost technologies. In the 1990s, a team at the Science Museum in London reconstructed John Harrison's marine chronometers from original plans. They proved that his designs were not just functional, they were centuries ahead of their time. In Switzerland, watchmakers began studying 1700s automata. They discovered programming systems and mechanical logic that rivaled early computers. The Reiter automaton was carefully restored and made functional again. When it dipped its pen and began writing, audiences witnessed a 250-year-old machine coming back to life. Engineers and makers have begun recreating these machines using both traditional techniques and modern tools. The knowledge is being recovered, one gear at a time. Museums worldwide are re-evaluating their collections. What was once dismissed as toy or curiosity is now recognized as sophisticated technology. The lost technologies of the 1700s are teaching us a crucial lesson. Progress is not linear. Sometimes we move forward by looking backward. The lost technologies of the 1700s challenge our assumptions about progress. We tend to believe that newer is always better, that efficiency is the highest virtue. But the craftsmen of the 1700s valued different things: precision over speed, artistry over volume, longevity over disposability. Their machines were built to last centuries, not years. They were designed to inspire wonder, not just perform function. They represented the pinnacle of human skill. Today, as we face the environmental cost of mass production and planned obsolescence, perhaps it's time to reconsider the values of those 18th-century masters. The lost technologies of the 1700s are not just historical curiosities. They are reminders that there are multiple paths to the future, and sometimes the path forward requires us to reclaim what we left behind.